Gazing into the night sky, it's easy to be awed by the grandeur of our universe. It's not just that space is big, it's that our place in it is so little. And as our knowledge of the universe has grown, so too has the realization that most of it is completely unsuitable for life. Between the searing heat of the stars and the frigid depths of space, it's clear that life as we know it can only survive by clinging to those few rocky planets that are lucky enough to exist in the narrow zone between too hot and too cold. While the rest of the universe can be breathtakingly beautiful, it seems utterly indifferent to our existence. But what if it's just the opposite? What if all this is here because we're here?
It's called the Anthropic Principle. It's the idea that our cosmic reality is a product of the fact that we're living in it. That may seem like a backwards argument, but some cosmologists say it may be the only way to explain why the universe is the way it is.
In ancient times, the universe didn't need that kind of explaining. With so much order and complexity in the world, it was logical to imagine that a divine being of some kind just made it that way. Yet, in ancient Greece, philosophers took a different path. They tried to explain the universe in terms of natural laws. In many cases, they guessed wrong about the causes of various phenomena, and also about our place in the universe. For example, Aristotle argued that Earth had to be at the center of the cosmos, with the stars and planets circling around it. But while this conclusion was mistaken, the approach taken by Aristotle and other philosophers would eventually develop into modern science, with its emphasis on observation and reasoning. It was a progression that took many centuries, but by the early 1500s, our current understanding of the universe was starting to emerge. The key step was taken by Nicholas Copernicus, a Polish church official and administrator who was also a brilliant astronomer. Copernicus realized that the motions of the planets made a lot more sense if the Sun, rather than Earth, was at the center of the solar system. When Copernicus's ideas were published after his death in 1543, the scientific revolution began. At first, the Copernican system was controversial for religious reasons, but also because it seemed to defy common sense. After all, to any observer standing on solid ground and looking up at the night sky, it really does seem as though Earth is at the center. But Copernicus's great achievement was finding a deeper logic to the natural order of things. That logic tells us that it makes little sense for Earth to be at the center of everything, because that would mean humans just happen to be living at the most special place in the universe. For centuries ever since, astronomers have embraced what's now known as the Copernican Principle. The principle states that our place in the universe is very unlikely to be uniquely special. Rather, the way we perceive the universe is likely pretty close to what other observers would experience from their locations. In the 20th century, this premise became the bedrock of modern cosmology. Once astronomers realized that nearly all the galaxies are moving away from us, the Copernican Principle pointed the way to a dramatic discovery. It's not that we're at a special place that the galaxies just happen to be receding from. Rather, all of the galaxies must be moving away from each other as the entire universe expands. Our location may have its own particular details, but the universe looks about the same no matter where you are. As telescopes improved, the Copernican Principle continued to fit the accumulation of evidence. The universe has turned out to be full of galaxies similar to our own, stretching off in all directions for billions of light years. We're not at the center, and neither is anyone else, because as far as we can see, the universe has no center and no preferred direction to look. But cosmologists were beginning to notice something curious. While our view of the universe may not be special, the universe as a whole does appear to be very special indeed. What makes it special are the laws of physics that govern our reality. And as cosmologists started to consider these laws more closely, they found themselves heading in a new direction, one that for the first time in nearly 500 years was leading them away from Copernicus. Our universe is a place of extraordinary diversity. And from the planets of our solar system to the distant galaxies, the more we explore, the more variety we see. But underlying this variety is a deeper, simpler picture. So far, just about everything we've observed can be explained with a basic set of natural laws. These are the rules that dictate how matter and energy behave. They include the properties of fundamental particles and the forces that operate between them. But while these rules explain a lot, nothing seems to explain why the rules are so perfectly set up to produce a universe that can support life. Take gravity, for example. Relative to all the other forces in nature, it's extremely weak. That's why a toy magnet can easily overcome the gravity of the entire Earth and lift up a paper clip. But if gravity were any stronger, the result would be a disaster. In such a universe, the matter inside stars would be squeezed together more tightly. This would speed up nuclear reactions and cause stars to burn out sooner. With just a modest increase in the force of gravity, no star would last long enough for life to appear and evolve. Yet, if gravity were much weaker, then stars wouldn't shine at all. In the same way, particle physics is full of what seem to be chance numbers and relationships that we depend on for our existence. The neutron and the proton are almost equal in mass, but the neutron is slightly heavier, by about 0.14%. If it were the other way around, atoms wouldn't exist. A more subtle example suggests that our universe is perfect for the emergence of life based on carbon, the only kind of life we know. Carbon atoms have the property that they can readily form long chains, which are essential for large organic molecules, the kind of molecules needed to make working cells. but carbon forms only in the cores of stars. And when physicists began to work out exactly how that happens, they discovered a curious puzzle. It takes 12 particles to make the nucleus of a carbon atom, 6 protons and 6 neutrons. Stars build up carbon by starting with helium. Each helium nucleus has 2 protons and 2 neutrons. First, 2 heliums come together to form beryllium-8. Beryllium-8 is highly unstable and likely to fall apart in less than a trillionth of a second unless one more helium comes along. In stars, that happens often enough. But here's the problem. When you add beryllium and helium together, the result has too much energy. Instead of making carbon, they should just fly apart. In 1953, the British astronomer Fred Hoyle realized there was a way around this problem. He predicted there was an excited form of carbon that closely matched the higher energy level of beryllium plus helium. Hoyle was right. The excited carbon state was discovered soon after his prediction. Its existence makes it far more likely that beryllium and helium will morph into carbon once they've come together. But why is the energized state of carbon just right to allow this to happen? To understand why this is a problem, imagine pressing the emergency button to stop a fast-moving elevator. Then the door opens, and you discover that the place where the elevator has stopped perfectly matches a floor where people can step off. In other words, it's sheer coincidence. Yet it's a coincidence that we owe our lives to.
Over the years, physicists have come across other examples like this. Cases where if the numbers were changed just slightly, we wouldn't be here. No one would be here. It's this realization that's brought us to the Anthropic Principle.
The term was coined in 1973 by the Australian cosmologist Brandon Carter, who divided the Anthropic Principle into 2 versions. The weak version is simply the argument that our place and time in the universe is special because it's compatible with the existence of life. If it wasn't, we wouldn't be around to experience it. But there's a stronger version too, which suggests that the universe isn't possible unless at some point it allows life to evolve. Otherwise, the laws of physics are just too much of a coincidence. Once Carter formulated these definitions, it became clear that the Anthropic Principle presents a challenge to the traditional way of doing science. Ever since Copernicus, astronomers have been working on the premise that the universe is independent of our presence in it. With this premise in mind, many cosmologists resisted the Anthropic Principle, hoping that scientific progress would eventually lead us to a better understanding of the laws of nature. But then, a surprising development put the Anthropic Principle back in the spotlight, along with a stunning theory about the true nature of our cosmic reality. In 1998, astronomers made a discovery that would forever change our understanding of the universe. They found evidence for dark energy, a mysterious phenomenon that permeates all of space and is causing the expansion of the universe to speed up. This is big news because it helps explain everything from the age of the universe to its long-term future. But the presence of dark energy also carries huge implications for the Anthropic Principle. Of all the cosmic coincidences that seem to make our universe suitable for life, dark energy may be the biggest coincidence of all. This is because the density of dark energy is so extraordinarily small. Just a tiny fraction of a fraction of a fraction more than zero. So far, there's nothing in the laws of physics that predicts why dark energy density should have such a minuscule value. It seems to be completely arbitrary. Yet with just a little more dark energy, the early universe would have expanded too quickly for matter to come together to form galaxies. Without galaxies, there would be no stars, no planets, and no possibility of life. For scientists, this is a philosophical problem, because how can you explain a universe that seems to be tailor-made for us? In fact, the discovery of dark energy has now been used in some religious circles as an argument for why there must be a divine creator. But scientists have found another way of looking at the problem. Consider the case of Earth in our solar system. Among the planets, Earth seems uniquely well positioned for life. If it were a little bit closer to the sun, it would be too hot. If it were a little bit farther, it would be too cold. There's no reason for Earth to be at just the right distance from the sun for life to flourish. So is this another example where scientists have to take the Anthropic Principle into account? The answer is no, for a very obvious reason. Earth is not the only planet. In our solar system, there are several other planets, and many more have been discovered around other stars. It's estimated that there are billions of planets in our Milky Way alone, each with its own characteristics and temperature. That means Earth is no coincidence. It's just one of billions of possibilities. And since we can only exist on a planet like Earth, it makes sense that this is the kind of planet we happen to be living on. Now, cosmologists have applied the same reasoning as a way of dealing with the Anthropic Principle. Because what if our universe is not the only one? Instead of one universe with one set of physical laws that just coincidentally happen to be perfect for life, what if there are countless other universes in which the laws of physics can come in any possible form? This larger picture of reality has become so compelling that cosmologists have given it a name. It's called the multiverse. If it's true, then as vast as our universe may seem to us, it's merely a bubble in a multi-dimensional cosmos where other universes are popping up all the time, each with its own value for dark energy. Since only a very, very few of those universes would be livable, then it's no coincidence that we find ourselves living in one. It's a startling conclusion, and even though it hasn't been proven, it's supported by two different fields of research. One is string theory. It's a mathematical method of explaining the laws of nature that turns out to have a vast number of possible solutions. Some theorists now say all those different solutions correspond to different universes in the multiverse. Secondly, scientists who are probing the early universe have found that what they're seeing is consistent with a theory called cosmic inflation. The idea is that our universe emerged from a small patch of space that released energy by inflating at an exponential rate. If that's correct, then other universes should be doing the same thing in an eternally inflating multiverse.
There are plenty of reasons to be cautious about this picture. For one thing, it means we have to conjure up a vast number of other universes just to explain this one. And if it's true, it means there will never be one set of physical laws that predicts our reality, because in the multiverse, so many other realities are equally possible.
As strange as it seems, this picture may be our only way of explaining what astronomers have found. Because of the multiverse, the Anthropic Principle is now at the center of one of the most fascinating debates in the history of science. It's a debate that involves everything we know about the universe and possibly everything we can know. Where that debate will lead us is still unknown, but it will surely be shaped by what we learn as astronomers continue to probe the universe to its limits. In the meantime, we already know that despite the Copernican Principle, there is one way in which our perspective on the universe is special. Because it's only in our lifetime that humanity finally has the tools to reveal how rich and potentially vast our cosmic vista truly is.